Hey guys, so welcome back. In this lesson, we're still talking about elimination, but this time we're going to do the final step, elimination using multiplication. You did a little bit of that on the second page from the previous lesson, but we're going to go a little bit more in detail. So first thing you need to do is you need to pause the video. Definitely pause the video, and I want you to read through these two examples I've got circled. Go ahead and do that now. Okay, great. Now, I will go ahead and tell you it may be necessary for you to work some of these out on notebook paper, and that's totally fine. Let's go ahead and look at a couple of examples. And I'm going to try and just zoom in enough so that I don't have to use notebook paper. We'll see how that works out. So number one, we have the system 2x plus 3y equals 6 and x plus 2y equals 5. So we can't just add both of these equations and have the x's or the y's cancel. That's not going to happen. And I can't multiply one of them by -1 and have either the x's or the y's cancel either. So I'm going to have to manipulate these equations so that either the x's or the y's cancel. So how do I do that? Well, first you need to decide. Do you want the x's to cancel or do you want the y's to cancel? There's no right or wrong answer here. It's just your preference. In this case, I'm going to have the x's cancel. If the coefficient of this x was a -2x, then my x's would cancel very easily. So how can I make the coefficient of this be -2x? Well, I can't just stick a -2 there. But remember in the last lesson how I multiplied everything through by -1 to change the sign? Well, I can do something similar. I can, oops, wrong. Hold on just a minute. I changed the thickness. I can multiply this whole equation through by -2. Let's see if I can get that to work now. There we go. So I'm going to multiply everything through by -2. And then the coefficient of that x would be a -2 and the x's will cancel. So first thing I'm going to do is I'm going to rewrite that very first equation. So there we go. So that's going to be, 2x plus 3y equals 6. So I'm just rewriting that one. The second equation is going to become -2x minus 4y equals -10. Zoom in here. So now I can add these two equations together. The x's will cancel. So that leaves me with 3y plus -4y. So that'd be -1y. And then 6 plus -10, it's going to be -4. So if -y is equal to -4, then y would be +4. So now that I know the value of the y coordinate, I can find the value of the x coordinate, and I can do that similarly. So just like I did in previous examples. So I'm going to use the second equation. I'm going to use that x plus 2y equals 5. I'm going to write it over here on the side. X plus 2y equals 5. And then we know that y is 4, so 2 times 4 equals 5. So that'd be x plus 8 equals 5, which means that x is equal to -3. Remember that the solution to a system is an ordered pair. So the x coordinate is -3, the y coordinate is +4. So the solution to that system is going to be the ordered pair -3, 4. Again, you may want to use notebook paper for this. All right, let's try another one. Let's try number 4. I'm going to change colors that I'm writing with, so that way, like I said in previous lessons, that the work for number 1 doesn't get mixed up with the work for number 4 and so on. So in number 4, the x's won't automatically cancel if I add the equations together, and neither will the y's. So how can I make it so that either the x's or the y's cancel? Well, this one's not as simple as number 1. In this case, again, you need to first decide, do you want the x's to cancel or do you want the y's to cancel? Well, there's no right or wrong answer here. However, I do see that the y's have opposite signs. So let's let the y's cancel. How could I get the y's to cancel? Well, I've got a positive 5y and a negative 7y. So think about least common multiple. Remember that way back when? You probably learned about least common multiple at least in 6th grade, if not before. Well, if I change that 5y to a 35 and the negative 7y to a negative 35y, then they'd cancel. In order to do that, the 5y would have to be multiplied through by 7, and the negative 7y would have to be multiplied through by 5. This is the most complicated type of elimination, where you have to multiply both equations by a number. All right, so when I do that, the first equation becomes 28x plus 35y equals 42. And my second equation is going to become 30x minus 35y equals negative 100. Now I'm going to add them together. So those y's will definitely cancel. So I'm going to do 28x plus 30x. So that's 58x. And I'm going to do 42 plus negative 100, which is going to be negative 58, which means x is negative 1. Now you got to find the value of y. Now you have 4 equations that you can choose from, right? You can choose this one or this one, the 2 new ones, or you can use one of the original equations. So it's usually easier to use one with smaller numbers to work with here. No one particular equation is easier necessarily or better than the others. I'm just going to pick the 4x plus 5y equals 6. So let me write that down. 4x plus 5y equals 6. So I know the x is 1, so 4 times negative 1 plus 5y equals 6. So that'd be negative 4 plus 5y equals 6. Add 4 on both sides. 5y is 10. So y is 2. So the solution is the ordered pair negative 1, 2. Okay. Let's try one more. Let's try number 7 together. So we've got 4s minus t equals 9 and 5s plus 2t equals 8. Now, I can make the s's or the t's cancel. It'll be a lot easier to make the t's cancel, and the reason being is because the coefficient of this one is negative 1. First off, the t's have opposite signs, so that makes it a little bit easier. And if the coefficient of one of them is a 1, all I have to do then is multiply the top equation through by 2 and be done. I don't have to do anything to the second equation. So I'm going to rewrite this. So that'd be 2 times 4s. So that's 8s. 2 times negative 2t equals 18. And the second equation I didn't do anything to, but I'm just going to rewrite it because I like it for them to be written one under the other. I also want to point out that notice my variable t, when I wrote it, I curved the bottom of it so that it doesn't end up looking like a plus sign. I highly, highly recommend you do the same. All right, so let's add these two together. The t's definitely will cancel. 8s plus 5s is 13s. And then 18 plus 8 is 26. Divide both sides by 13. 26 divided by 13 is 2. So now we know s is 2. So I suggest either equation. Let's do 5s plus 2t equals 8. So 5s plus 2t equals 8. We know s is 2. 5 times 2 plus 2t. So that'd be 10 plus 2t equals 8. And then subtract 10. 8 minus 10 is negative 2. And then divide both sides by 2. Negative 2 divided by 2 is negative 1. When I write this ordered pair, they didn't use x's and y's. Instead, they used s's and t's. Think about which one comes first in the alphabet. S comes before t, so treat the s like it's your x coordinate. So that would be 2, -1 would be the solution to this particular system. Okay, so you're going to go ahead now and you're going to do problem 10, 2, 5, 8, 11, 3, 6, 9, and 12. You can skip 13 and 14, but go ahead and do the rest of the problems on this sheet. So let's pause the video and work on those now. Okay guys, welcome back. Hopefully you did okay with these particular problems. Again, you may have chosen to work them out on notebook paper, and if so, that's fine, but you do need to have work shown for each problem. So I'll start off by showing you the work I've done for problem 10. Again, when you're looking through these, first check over the solution, the ordered pair. Did you get the same ordered pair that I got? If so, then your work should be correct, even though you might have taken a different path from me, and then you can move on. If you don't have the same solution that I have, then you need to go back and compare your work against my work to see where you may have made a mistake. So here's number 10. And let's see. There, you should be able to see 2, 5, and 8. There's number 11. And 3, 6, and 9. And number 12. I do want to point out for number 12, I left my answers as improper fractions because I ended up with repeating decimals. So I wanted, when I found y, it was a repeating decimal. So I used it as an improper fraction to get the exact value for x. So those ordered pairs look a little funny. Just remember that if you changed yours to decimals, yours might be slightly off from mine. Again, number 12 is definitely one that I would not have wanted to solve by graphing. That one would have been much more challenging. Okay, so again, as I say every time, any questions, make sure that you ask me for assistance if you don't understand something. Go ahead and let's turn this in, and you're ready to work on your independent practice. Good luck.